I'm going to do a tutoring here for a bit of Monster Math Fakie 2. I want to start off with this though. What do we need? All right, we have three fundamental type rules. I need a x alone and on top. All these numbers move diagonally through the equal sign because we're not doing the kind of equation where we're going to add and subtract across the equal sign. We're only going to multiply and divide, which means essentially they move diagonally through the equal sign. And this is the part that seems to be throwing the most people. How do I undo a root? I undo it with a power. How do I undo a power? With a root. So I have a secret number. The square root of my secret number is 4. Well, what's my secret number? Of course, it's 16, isn't it? But let's go through and do it formally. I'm going to undo my second root, my square root, with a second power, with a squaring power. This unzips back and gives me just plain old x. But you had to do it to both sides of the equal sign or it doesn't work. It doesn't give you the right answer. So I'm going to square 4 and look, it proves what I already knew. The secret number x must be 16. The opposite version is I have a secret number, and when I square my secret number, I get 25. Well, my secret number must be 5, right? Because 5 squared is 25, but let's do it formally. To undo the squared power, I'm going to take the square root. Or to undo the second power, I'm going to take the second root. But I must do it to both sides. This unzips and gives me regular old x. And I take the square root of 25 and I get 5. So how about we do 6, 7, 8? I need x alone and on top. Well, they are separate, right? So let's get them on the same side. It is a lot faster if you will do this so that the x with the greater power ends up on top. It'll save you a lot of time and trouble. So I'm going to swap the 8 here and the negative x here. And that's how I got this, because my negative x comes down here and it cancels out one of the x's here, because I had x squared over negative x to the first, right? And this 2 cancels out one of those. This all cancels out and I get just x, except remember it's now negative x because I take it back. It looks like I canceled out negative. I only canceled out the x part, not the negative part. And I get negative x to the first on the left side. And if you want to be extra picky, it's over 1. The 8 moved up here. This is negative 16. So I have negative x equals 8 over negative 16. That means negative x is, simplify this, equal to negative a half. If you want to be really formal about it, you can go back to sort of 7th grade math and realize that you can multiply both sides by negative 1. You can always do that though. You can flip the sign of both sides as long as you do both sides, because I need to get positive x. And so positive x is equal to positive a half. Or to say it another way, when I take the opposite sign of my secret number, I get negative 1/2. Well, my actual positive secret number then must be positive 1/2. Again, I have x separated and it has to move diagonally. Let's bring them together this time. Realize that this is x times x and then it's times another x. So when I move this up here, I get x to the third power. You could immediately move the 0.7. I don't care. I didn't at first, but you could. This is 14. This is 42. So I ended up with this. Remember that when I drag the x squared, I leave a 1 here. It is not blank. It's not a 0. It's 1 when you just drag something out of the place in the fraction. So now I'm going to drag this down here and this up here, and I get this. Using a calculator, I figure out that this is 840, and I have a power here. X to the third power is 840. So how do I undo a power? With a corresponding root. So I will take the third root, and this will unzip here and give me regular x. And I must take the third root of both sides or it doesn't work. And then I find out on my calculator that this is 9.44. How do I do that? By the way, on the calculator, if you have one of the ones that they have been handing out from the library, we can get these functions by using the corresponding button here. So shift third root of, and then type 840 and equals, and like I said, it rounds off to 9.44. How about 8? Now, another point I made way back with the monster math is that x to the 1/3 power is the same thing as cube root x. And I've had some kids trying to undo x to the 1/3 power with cube root x, but you can't undo it with itself. These are the same thing. I don't care which way you write it. This is the same thing. So they don't undo each other. We can just rewrite it as cube root x, and that's what I did here. This is 12, this is 4, and what I did is I traded these so that x could be on top. And notice I changed it to cube root x because these are the same thing. I don't care. You can leave it as x to the third if you want. And then my 4 was up here and still, and I traded these two. X needs to be on top and alone. It is not alone, so let's move the 9. Technically speaking, you left a 1 on the bottom, but it doesn't really matter. I didn't bother to write it. 9 times 4 divided by 12 is 3. So what I have is cube root of x equals 3. How do I undo a cube root? With the corresponding power. So I will take cube root of x to the 3rd power, all of it. Notice the parentheses. That unzips to give me regular x, but I must do it to both sides. So I take 3 to the 3rd power equals 27. Plus, this says my secret number when I multiply it, this says I have a secret number, and when I discovered the thing that multiplied by itself using 3 of them, that turned out to be 3. So I'm saying something times itself equals my secret number, and the thing that I used was 3. So 3 times 3 times 3, right? And this just makes me go and do it. It makes me realize what I'm doing. 3 to the 3rd power, and it's 27, isn't it? Because that's true. My secret number is 27 because 3 times 3 times 3 gives me the secret number of 27.